All right, guys, here goes another round of Miss Oxley's homework help via video. First things first, let's make sure you put your name first and last, please, and then your period. So if I'm in period 3 and 4, I'd write 3 and 4, or 5 and 6, or whatever you have. Okay, so first of all, get in the mindset that we're working with a graph. Before I even read this stuff, I come over here and I look at my variables, the title on my x-axis and my y-axis. Automatically, I know that, by the way, this is your input and this is your output if we're talking about a machine. So we're talking about the miles per hour over the speed limit, and we're talking about the amount of fine. So ask yourself, what do you think this problem is going to be about? I would think it's about speeding tickets, which I only have a couple of. We won't talk about it. So it says, when a driver gets caught speeding in a certain town, the fine is determined by the graph shown here. Complete the following statements by filling the blanks. Before we look at this, let's address what's going on here. Make sure that you underline this is over the speed limit. Make sure you realize this is 5, 10, 15, 20, 25, 35. So my scale is 5 here. If this is 100, this is 50. This is 150. This is 250. I always fill in those scales so I don't have to make my brain work so hard. So if I'm 5 miles an hour over the speed limit, that doesn't mean I'm going 5 miles an hour. It means I'm going 5 miles an hour over the speed limit. I'm going to pay $50. If I'm at 10, I'm going to pay $100. If I'm at 15 miles an hour over, I'm at 150, so on and so forth. So let's see if we can answer these questions. Going 20 miles per hour over the speed limit will result in a fine of. So we're asking about this. So when I draw my line, I'm going to draw my line towards the money. If that's what I'm asking about, if that's what they're asking me for, the line that I'm going to draw is towards the money. So find 20 miles an hour over, meet up with your line, and draw a line straight over. At 20 miles an hour, I'm going to pay $200 in fines. Going 40 miles an hour over, what's the result of the fine? 40 miles, I'm going to get $300. If a driver received a fine of $150, then the driver must have exceeded the speed limit by. Again, now they're asking for this. So I'm going to follow my line, and my line is going to hit here. Find $150, come over, hit your line, drop it down. For $150, that means you were going 15 miles per hour. I have a second question for you. At what miles per hour over the speed limit will I always pay $300? Good, 30 to 50. It doesn't matter if I'm going 30 miles an hour, 31 miles an hour, 42 miles an hour over, 45 miles an hour over, 46 miles an hour over. Anywhere between 30 and 50 miles an hour over the speed limit is $300. By the way, if you were going 50 miles over the speed limit, you should have your driver's license taken away. Okay, next. Rectangular tables are arranged in a row, with chairs around each row as shown in the picture. Okay, so we can fit 1, 2, 3, 4, 5, 6. We can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's a relationship. Remember that word relationship lets you know that there's going to be a machine. In this machine goes in the tables, table number, and comes out the chairs. Whatever the machine is, if I put in 1 table, I get out 6 chairs. If I put in 2 tables, I get out 10 chairs. If I put in 3 tables, I get out 14 chairs. There's a relationship between the number of chairs and the number of tables that can fit in the row. Answer the following questions. If the pattern continues, well, let's see. How many chairs will fit around a row of 5 tables? Well, let's think. I'm adding 4 each time. So 4 tables would be 14 plus 4 is 18. 5 tables would be, add 4, 18, 19, 20, 21, 22. So I've got 22 chairs. How many chairs will fit around a row of 11 tables? Well, instead of making a whole table, why don't we try to figure out the relationship between 5 and 22, 4 and 18, 3 and 4. So remember what I do. I always pick a number 1 through 5. I'm going to pick 3 and try it first. If I multiply this by 3, 5 times 3 is 15. To get to 22, I'd have to add 16, 17, 18, 19, 20, 21, 22. So 7. Let's see if that works up here. 4 times 3 is 12. plus 7 is 19. So it's not 3. Let's try 4. If I multiply by 4, 5 times 4 is 20. And I had to add 2. So let's see if that works. 4 times 4 is 16, plus 2 is 18, so that worked. Let's try it up here. Times 4 plus 2. 3 times 4 is 12, plus 2 is 14, so it works. We have to take the number of tables, multiply it by 4, and add to 2. So let's talk about how many chairs will fit around a row of 11 tables. So if I put 11 tables into my machine, I'd have to multiply it by 4 and add 2. 11 times 4 gives me 44, plus 2 is 46 chairs, if I could spell. How many tables? So now they're asking, what did I put in my machine to get out 30 chairs? Well, we know it's between 5 and 11 because we went from 22 chairs to 46 chairs. So let's see. I'm going to guess 7. If I put 7 into that machine, 7 tables, I'm going to multiply it by 4 and add 2. 7 times 4 is 28, plus 2 is 30. Oh, I got it right. I promise that was just a good guess. So 7 tables, if I put it in that same machine, 7 tables times 4 plus 2 will give me the 30 chairs. In these, what they're doing is asking you the opposite. They're asking you, what number do I put in the machine to get out a 30? These are saying, put 11 in the machine and you get out chairs. And just for practice, let's say that chairs are C and T is tables. We always start with the output when we're coming up with a rule. So my rule would be the number of chairs is always equal to the number of tables times 4 plus 2. There would be my rule. Oh, that was a short homework. I'll give you a couple hints on your staying sharp. Both of the, one of these is negative, one is positive. Find a rule like this, just like we did. So your rule would be y equals some number times x plus or minus some number. You got to check. I would try 3 first maybe and see what comes out. Number 3, in this sequence, term number 1 has a value of 6. Term number 2 has a value of 12. Term number 3, so here's my first number is 6, my second number is 12, my third number is 22, my fourth number is 36, my fifth number is 54. If n represents the term number, so this is n up here. The term number is 1, the term number is 2, term number is 3. Demonstrate that the rule 2n squared plus 4 will generate the sequence. Okay, so they're saying that 2n squared plus 4, if I take n, square it, multiply by 2, and add 4, I should get the number on the bottom, my output. So let's double check. If I take my first n, if I take my first n, which was 1, plug it in for n, 1 squared is 1. 2 times 1 is 2. Bring down your plus 4, plus 4. 2 plus 4 is 6. Got it. Let's try it one more time. If I take my rule, 2n squared plus 4, and let's plug in the second n now. So my second n was 2. PEMDAS says parentheses first. 2 squared is 4. Bring down my 2, bring down my plus 4. 2 times 4 is 8. Bring down my plus 4. 8 plus 4 is 12, and that's what we're supposed to get. So that rule, taking n, squaring it, multiplying by 2, then adding 4, does in fact work for that. Describe the relationship by this graph by writing a function rule relating y and x. Ooh, this is a hard one. I'll give you a hint. Oh, they gave you a hint. May help to make a table. I would make a table if when my x is 0, my y is 3. When my x is 2, my y is 5. When my x is 4, my y is 7. When my x is 6, my y is 9. Try to find the rule on how I can relate 6 to 9, 4 to 7, 2 to 5, 0 to 3. Okay, and then write the rule. And the rest you can do. All right, I'll see you tomorrow, guys.